So far we've covered the chain rule in this unit, and we've covered implicit differentiation, and now we're going to get into the derivatives of inverse functions, which leads to the derivatives of exponential and logarithm functions, and also the inverse trig functions, okay? So that's where we're headed with all this, okay? So this is just inverse functions in general today. Excuse me. All right. So this right here, this is the function of f of x is equal to x squared plus 3, where x is just greater than or equal to 0. So this is the graph of y equals f of x, okay? And so what I want to do is I want to graph the inverse function of f, okay? So the notation for that is this, okay? So f with a little like -1 exponent, that just means when you see that means the inverse function, all right? And what you have to remember is that when you do the inverse function, it's going to undo whatever the function was doing. So here the function, you put in 0 and you get out 3. So what the inverse function will do is you put in 3 and you get out 0. So the x's and y's, remember this, they switch. So it becomes 3, 0 is a point on the inverse function, okay? And then if we put 1 in, reading off the graph, if we put 1 in, we get 4 out, which means on the inverse function, if we put 4 in, we get 1 out. That'd be this point right here. If we put on the function, if we put 2 in, we get 7 out. That means on the inverse function, if we put 7 in, we wind up with 2 as an output, okay? And then we put in 3 and we get out 12. That means if we put in 12, we get out 3. So 1, 2, 3 right there. All right. And then when we put in 4, we get out 19. That would mean when we put 19 in, we get out 4. So that'd be right here. And so it looks like this. And it's actually the square root function. Okay. So it looks something like this. And it's going to keep going. Didn't quite get through that point. All right, just make the point bigger. No. All right, so this is, well, and I'm going to let f inverse of x, this, a lot of times this is simpler if we do this. We're going to let f inverse of x be g of x. And just, we're going to use the regular old function notation. So that what this means is this is the graph right here of y is equal to g of x, okay? All right, so what this means is if I take the derivative of this, okay, and this is how we'd have to write it. That's why we switched to this notation, and you'll see in just a minute. If I want to take the derivative of this, I would have to write it like this, and it's kind of a pain. So you'd have to have brackets around the inverse function and then put a prime. And here's why, because you can't put a -1 and the prime in the same spot, okay? So this is how we have to write it. So it's much easier if we call that g of x, and we just say g prime of x. And that's just the derivative of the inverse function. Just, it's out of convenience and easy. It's easier notation, okay? We just have to realize f and g are the inverse functions, okay? All right, so this is a big deal, okay? That the inputs and the outputs switch on us, okay? All right, and it's gonna be, you're gonna see, it's really gonna be a big deal that we understand that idea, okay? Okay, so there's going to be a lot of detail that I have to cover before we get to the problems. The actual problems when we go to do them are actually fairly easy to do, okay? But there's a lot of big ideas that we're going to use, okay? All right, so I want to find the inverse of f of x, okay? So remember, f of x is this function from above. F of x is equal to x squared plus 3 and x is greater than or equal to 0. This makes it, I don't know if you remember from last year, this is going to make it be 1-to-1, which means the inverse will be a function, all right? Okay, so we switch the f of x to y. So now we have y is equal to x squared plus 3. We still have x being greater than or equal to 0, all right? And then to do this, what we do, if you recall, we switch the x and the y, because that's what happens. So this y becomes x, and so we get x is equal to y squared plus 3. And this restriction that was on the domain, now actually this x gets swapped out to a y. So it's y that has to be greater than or equal to 0 for this, all right? Now I'm going to start solving this for y. So I'm going to subtract 3 from both sides. And that would give me x minus 3 is equal to y squared. And then I'm going to square root both sides. Okay, and remember the square root of y squared. This actually becomes the absolute value of y. So the absolute value of y is equal to the square root of x minus 3. Okay, and then to solve this, we get y is equal to plus or minus. Okay, all right, so y is equal to plus or minus the square root of x minus 3. Now, earlier we said y has to be greater than or equal to 0. Okay, if y has to be greater than or equal to 0, then it can't be the negative one, right? So y is equal to the square root of x minus 3. Or that's our inverse function, okay? G of x, which is the inverse of f, is the square root of x minus 3. All right. So what I want to do next is I want to find, and you're not going to understand why this is kind of like out of the blue, but there's a point to this, okay? I want to find f of 2. Okay? So f of 2 is equal to 2 squared plus 3, right? Because f of x is x squared plus 3. So f of 2 is equal to 2 squared plus 3. That means f of 2 is equal to 4 plus 3. So that means f of 2 is equal to 7. Okay, f of 2, if we put 2 in, we get 7 out into the f function. And right now I'm being weird and you're like, why is he saying like that? That's going to be important. I put 2 in and I get 7 out. All right, so big idea. Here's the biggest idea on this first page. This is huge, okay? I want us to find g of 7 without it doing a single calculation. So find g of 7 without any calculations. And there's a way to do it. Okay? No work at all. No work at all. I realize you can put it in here, but no work at all. Okay? Here's what you can do. All right? Usually I get somebody to tell me it, but we're on video, so it doesn't matter. I can't do that. All right? All right. It goes back to this. I know if I put 2 in, I get 7 out. If I put 2 in to the function f, I get 7 out. And f and g are inverse functions. So automatically, by knowing that you put 2 in and you get 7 out for the function, that means if you put 7 into g, which is the inverse function, we have to get out this 2. So that's what it is. G of 7 is equal to 2. So, okay, so what's g of 9? All right, so what's g of 9? Yeah, I realize you could put it in here, okay, all right, but one way we could do it is 9 is an input for g. That 9 is also an output for f. So an input to g is an output for f, okay? So what we need to do is we are going to need to solve, and this one's actually pretty easy to do, solve f of x. What input could I put in for f to get out 9? Well, that would be x squared plus 3 is equal to 9, which means x squared is equal to 6, which means I have to square root both sides, which means x, the absolute value of x, would equal the square root of 6, which means x would have to equal plus or minus the square root of 6. But, all right, for f, okay, for f, x has to be greater than or equal to 0. So it can't be the negative one, all right? So x is equal to the square root of 6. Okay, so what does that mean? Okay, we found the input that makes it 9. So that means f of the square root of 6 is equal to 9, which means g of 9 would have to equal the square root of 6. And so if you know one of these, you know the other one, right? Okay. Now, going back over here, we could double check, right? G of 9. Well, what if we put 9 in here, right? G of 9. What's 9 minus 3? 9 minus 3 is 6. Ah, the square root of 6. You see? I realize this is easier. We're not always going to be able to do this. Okay, so I want you to understand. So we can find, this is really important because there are going to be equations where we're not going to be able to find the inverse, yet we can still do this. Okay? All right. Okay, like perfect examples of trig functions. Okay? You're not going to be able to solve it, okay, like we did algebraically, okay? All right, so that's a big idea. That's huge, all right? This idea right here. All right. Let's go to the next page. From the previous page, okay, we know that f of x is equal to x squared plus 3, and x is greater than or equal to 0. And we also know that g of x is equal to the square root of x minus 3, and y is greater than or equal to 0. All right. So what is f of g of x? Okay. So f of g of x. Some of you might be able to tell me because you remember from last year, okay? But this is in case you don't. So that means, all right, we got to put the g of x function into the f function. So what is the g of x function? It's the square root of x minus 3. So really, you guys, all I'm doing is replacing this g of x with what it's equal to, the square root of x minus 3. Okay, now what does the f function say to do with whatever your input? Well, whatever your input is, you need to square it and then add 3. So that means this becomes the square root of x minus 3, and we're going to have to square that and then add 3. Well, what happens when we square a square root? Well, they're going to cancel each other out. They're going to undo each other. So what you're left with is x minus 3 plus 3, which is equal to x. And that should make sense, because we take x, the innermost piece, right? We're going to put that into the g. G does something to it, right? And if f and g undo each other, okay, g does something to x, you know, multiply by 2, add whatever, okay? Then the f is going to go take it and undo what g did, and you're going to be back with the x. So this should make sense, okay? If they're inverse functions of each other, all right, then this should do the same thing, right? So let's just verify that it does, okay? So we have g of f of x is equal to g of, okay, this time f of x is the inside function, so that'd be x squared plus 3. And then I need to put that where the x is for the g function right here, right? So this becomes the square root of x squared plus 3. I'm just using parentheses just to show you that's where I'm putting where the x was. That's where this goes. And then minus 3. All right. So this is equal to the square root of x squared, right? Now, okay, I need this right here, okay, because this could be plus or minus, right? This could be plus or minus x, but really it's going to be the positive because this is an output, and the output for g has to be positive, okay? So this becomes positive x, only because of this. All right, so big deal here. Big deal. Notice, okay, that if they're inverse functions, this is always true. This is going to allow you to find the derivative really quick. Like, you don't have to have this memorized. You can actually figure it out, okay? Notice this, that f of g of x must equal x. So we should have, I wish, we probably didn't, but it's okay. We should have already known this, okay? Because that's what inverse functions do, okay? Now, because we know this fact, and this kind of reassured it if we didn't remember it, okay, that's why I did this. that if I take the derivative with respect to x both sides, okay, I'm going to have, well, let's just do it. So I'm going to take the derivative with respect to x of both sides. So d dx of f of g of x is equal to d dx of x. Okay, this one, to find the derivative, we have to apply the chain rule. So this is f prime of g of x times g prime of x is equal to 1. All right, dx over dx if you wanted to, okay, but 1 still, all right? Which means g prime of x, which is the inverse of f, right? That's equal to 1 over f prime of g of x. All right. Now, if I had done g of f of x is equal to x, I could have come up with this. Okay. Now let me highlight this. Okay. This is only true. So, whoops. Okay. This is only true. Okay. If these are inverse functions. Okay. So this inside piece is the function we're trying to take the derivative of. So g prime, right? G prime, here's g, okay? So this is the inside function here is the function we are trying to take the derivative of. All right, and the f prime is the derivative of the inverse of g. So this is the derivative of this inverse. F prime is the derivative of the inverse of g. Okay. So I don't want you to get hung up on the F's and G's, all right? And F primes and G primes and all that, all right? Because I want you to understand the relationship here. And that is if we have F prime of X, and still F and G are inverses of each other, okay? This would equal to 1 over, okay, the derivative of the inverse of F, which would be G, so that'd be G prime of the function we are trying to take the derivative of, which would be f of x. And that's what I'm trying to say here, okay? All right. So usually I have everybody tell me this, okay? But here's I can't do it, all right? M of x and k of x, okay, two functions are inverse functions. Okay, so m of x, k of x, they're both they undo each other, okay? That's what it means to be the inverse functions, okay? So if I'm trying to find the derivative of m prime of x, so m prime of x, that would be equivalent to, using this idea here, 1 over the derivative of the inverse of m, which would be k, so k prime, of m of x. And that's the derivative of any inverse function. Okay, so what's the derivative of k prime of x? Well, k prime of x would be 1 over, okay, and all right, so what's the inverse of k? Well, it's m, so this would be m prime of k of x. And just a way to help you remember how it's placed, okay? But if you forget this, okay, if you happen to forget this, all right, you can always come up with it. The derivative you're trying to find, you want that to be the inside function, okay? All right. So you should know this now. Like that's easy. And then it's easy. We just take the derivative with respect to x of both sides and then solve for the derivative of the inside function and we have it, right? Okay. So you can always do it this way, okay? All right. All right. Let's go to the next one. So the derivative of any two inverse functions, okay, f of x has an inverse function and we call it f inverse of x and we're calling it g of x. So this right here, this statement, okay, you're going to see this on some problems, okay, on the AP exam. This is telling you we're calling the f inverse function g, okay, and g of x is differentiable at any x, and this denominator is not 0, okay, then this would be the derivative, okay. So once again, if we're trying to find g prime, then this would be the inverse of g, which is f prime, and then we're trying to find g prime, so the inside function of that is g of x, okay? I'm going to show you how this is all used in just a second, okay? And then to find so really to find the derivative of an inverse function, all we need is f prime and g of x. That's all we need, all right? Okay, so here we go. Calculate g prime of x, where g of x is the inverse of f of x equals x squared plus 3 for x greater than or equal to 0, okay? So, all right, so we want to find g prime of x first. So g prime of x, we know is 1 over the derivative of the inverse of g, which would be f prime of g of x. Okay, so this is the same function that we started with at the very beginning of the lesson, okay? So f of x is this, right? And g of x we got was equal to the square root of x minus 3, okay? And so f prime of x, because that's what we're going to need g of x, and we're going to need f prime of x. So f prime of x would equal, okay, so what's the derivative of f prime? Well, it would just be 2x plus 0, or just 2x, okay? So that means g prime of x is equivalent to 1 over f prime of g of x, right? And g of x is the square root of x minus 3 function. Okay, which means this becomes 1 over, okay, and we put the square root of x minus 3 into the f prime function, so that tells us just to double it. So this is going to be 2 times the square root of x minus 3. And that's how you can find the derivative of this inverse function, okay? Now, I'm going to go back, and you might be thinking, Mr. Mitchell, I could just take the derivative, write that as an exponent, and I can take the derivative, and I'll be done. Yeah, you're right. You're not always going to be able to find g of x, though, okay? All right, I get why you're saying that, all right? So here, g of x, like, we're going to show that if you take the derivative of this, it comes out to be this, all right? Which is kind of, I mean, this is kind of crazy. Like, to think that this works, it's kind of crazy, all right? So g of x, again, is the square root of x minus 3. To take the derivative, we would need to rewrite that as x minus 3 to the 1/2 power. And then now we could take the derivative of that, okay, using the chain rule and the power rule, okay? So g prime of x would equal 1/2 times x minus 3. And then I would have to take 1 away from this. So that would give me negative 1/2. And then take the derivative of the inside function, which would just be dx over dx, which would be 1, okay? So we don't need to write it. And then g prime of x would therefore be 1 over 2 times x minus 3 to the 1/2, right? Which really is, this is the square root, right? So g prime of x, sorry, got a little excited, all right, is 1 over 2 square roots of x minus 3. This is one of the, dang it, sorry guys. This is one of the things in calculus that just amazes me. Every year I do this lesson, it's like, who the heck thought of this, you know? And it's like, oh my gosh, who thought of this is just a genius, you know? So that this works, like something simple like this little simple formula. Okay, enough of my rant. All right, that's it for this problem. Let's turn the page and let's go to the next one. So on this next example, I want to calculate g of 7 and also g prime of 7, where g of x is the inverse of f of x, which is equal to 4x to the fourth plus 4x minus 1, okay? This is an example of one you would never be able to get g of x. I'm telling you right now, you're never going to be able to solve this for y equals and get what the g of x function is, okay? So you may wonder, like, how are we going to find g of 7? Well, here's the idea. It goes from the first page, okay? 7 is being an input for g, and since it's an input for g, it's an output for f, all right? So really what we need to do is we need to solve f of x is equal to 7. Because whatever this input is will be the output for g, right? Because inputs and outputs flip-flop, right? They switch. The input becomes the output becomes the input, all right? So now, this f of x, we have that function, right? It's 4x to the 5th plus 4x minus 1. So 4x to the 5th plus 4x minus 1 is equal to 7. Now, there's no way in heck you're ever going to be able to solve this algebraically. You can't, all right? So what we're going to do is we're going to solve this graphically with the graphing calculator. Okay, so what we're going to do is in our graphing calculator, we're going to let y sub 1 equal 4x to the 5th plus 4x minus 1, and we're going to let y sub 2 equal 7. Set those, find where they equal, okay? So I'm going to go to my graphing calculator right now, okay? And I'm going to solve this, and that will give me my x value, okay? So I'll be back in just, well, let's go to the graphing calculator right now. I'm going to show you this. So what we want to do is we want to type y equals, and then for y1, like I said earlier, we want to do 4x raised to the 5th, and then plus 4x, and then minus 1. And for y2, we want to set that 1 to 7. And then I would just press zoom, and then zoom standard for number 6. And there we go. Okay, so right here's our solution. All right, so what we want to do next is go second trace to access the calc menu. And then we want to do intersect, so we want to select number 5. And then first curve, we've done this before. So first curve, just press enter. Second curve, enter. And then whichever one it's, whatever, if there's more than one intersection, you get the one closest to it. So this is the one. So what is this telling us? This is telling when we solve this equation that x equals 1. Okay? All right, so let's go back to our notes and we'll finish this up. So from our graphing calculator, we wound up getting x is equal to 1. Okay, so what does this mean? Okay, we solved this for x, right? Which means f of 1 is equal to 7. Now, because f and g are inverses of each other, now this means g of 7 is equal to 1. And we found g of 7 without ever finding g. Like, blows me away. Blows me away every time I do this. All right. So now, okay, now we want to find g prime of 7, right? So we know that g prime of x must equal 1 over the inverse of g, which is f prime of g of x. Okay, so and we're gonna need f prime, right? So let's go ahead and do it. So f prime of x will equal 20 x to the 4th plus 4. Okay, so now here we go. G prime of 7. G prime of 7 is equal to 1 over f prime of g of 7, which means this is 1 over f prime of, and that's why I had you find g of 7 first, of 1. So this is equal to 1 over 20 times 1 to the 4th plus 4, right? And so that would just be 20 plus 4. This is 1 over 24. That's the derivative of 7. What the heck? We found the function value of g, right? And we found the derivative without ever even looking at or knowing what the formula is for g. Like, that's nuts. That's nuts. All right? You guys are like, calm down. All right. Okay, let's go to the next problem. So from here on out, all of these next examples all came from AP exams. Okay, so these are all AP exam questions. All right. So let f be a differentiable function such that f of 3 equals 15, f of 6 equals 3, f prime of 3 is equal to -8, and f prime of 6 is equal to -2. The function g is differentiable, and g of x and f inverse of x are the same. So what this is telling us is f and g are inverse functions, okay? What is the value of g prime of 3, okay? So to find g prime of 3, g prime of 3, that would equal 1 over, since f and g are inverse functions of each other, this means f prime of g of 3. Okay, so how do I find g of 3? G of 3, g of 3. Well, is this g of 3? No. That would be, this actually is telling us g of 15 is equal to 3. This one's telling us f of 3 is equal to 6. Sorry, I said f. G of 3 is equal to 6. F of 6 is equal to 3, which means g of 3 is equal to 6. Sorry, I said that wrong. Okay, so that's it, right? That's the g of 3 that we need. So that makes this 1 over f prime of 6. And if we look, f prime of 6, they gave it to us. It's -2. So this is 1 over -2, or -1/2. And that's the derivative of g prime of 3. And in this problem, we didn't even have f or g, right? Like, blows me away. Blows me away. All right, next problem. Let f be the function defined by f of x equals x cubed plus x. If g of x equals f inverse of x, okay, so f, that's telling us f and g are inverses of each other. G of 2 equals 1. What is the value of g prime of 2? Okay, so here we go. G prime of 2. Well, because g and f are inverse functions, this is equivalent to 1 over f prime of g of 2. Well, they tell you right here, g of 2 is equal to 1. So this is equal to 1 over f prime of 1. Okay, f prime of 1. Well, I don't have f prime 1. Well, no, but I do have f of x, right? So I can get f prime of x by taking the derivative, which would be 3x squared plus 1. So that means g prime of 2 must equal 1 over 3 times 1 squared plus 1. Well, that'd be 1 times 3, 3 plus 1 is 4, right? 1/4. So that means g prime of 2 is equal to 1/4. Booyah, right? Okay, so this problem is, and this came from a free response question a few years ago, all right? If this is the inverse function of g, write an equation for the line tangent to the graph of y equals g inverse of x at x equals 2. Okay, so because we're using g and g inverse and we're not using f, we got to use the, it's clunky notation, okay? But I need the derivative of this, right? Okay, so the derivative of this, let's talk about this. I would write like this: g inverse of x prime. Okay, this is equivalent to 1 over, all right? And we need the inverse for g inverse. So the inverse for g inverse is actually g, okay? And it's g prime of g inverse of x. And this is where it gets, I know it gets cumbersome here, okay? So these need to be inverse. If it's g inverse that we're taking the derivative of, the inverse of that is g, right? G and g inverse undo each other. If we're finding the derivative of g inverse, this has to be g prime because they're the inverses of each other, okay? So that's why this is g prime. Just like if this was f and g, if this was g, then this would have to be f, right? Because they're inverses of each other, okay? So g is the inverse of g of this, all right? It's kind of weird to say G is the inverse of G inverse, but that's what it is, okay? All right, so we need to find this at 2, and we also need to find G inverse of 2, right? Because we need that point, G inverse of 2, okay? Because that's going to be the point on our function, okay? All right, so how do we find G inverse of 2? Okay, so what this is this is G, and these are my X values, and these are the outputs for these inputs, okay? So if we put, this would be G of 2 is equal to 3, okay? G of 2 is equal to 3. All right, so we actually need to think of this as backwards, right? We need to go from the output of G right here. These are the outputs, right? Because outputs of G are the inputs for G inverse. So these outputs, here's my 2, right? And it's going to be 1, okay? Because G of 1 is equal to 2. Hopefully that helps. G of 1 equals 2, so G inverse of 2 is equal to 1, right? They undo each other. Okay, so back over here, this is going to be 1 over G prime of, hold on, I should have written this. G inverse of 2 prime. All right, so this is G prime of G inverse of 2. That was wrong if I had left it, because then I'm saying these are the same and they're not. Okay, these two are the same and these two are the same, but they're not. They don't cross over. Okay, so G inverse of 2 is 1. So this is equal to 1 over G prime of 1. And now, because this tells me G prime, all right, values for G prime, here's 1. So that makes this 5. So this is equal to 1 over 5. Now, that's the slope of my tangent line, okay? That's the slope of my tangent line. And we want the line of the tangent line to the graph of G inverse, not G, but G inverse. So we want to use this one, right? So I now know that G inverse of 2, the derivative of that, is equal to 1/5. And I also know G inverse of 2 is equal to 1. So there's my point, and this is my slope. So it would be y is equal to 1/5 times x minus 2 plus 1. And that would be my equation of my tangent line. Okay? This is hard, and what makes it harder than the other ones, is this notation, right? We got to use the prime, right? And you see the little -1, and it's hard. It is hard. It's even hard for me. I have to think through this every time I do this problem every year, okay? Because I got to realize that G inverse, okay, and G undo each other. So G inverse and G undo each other, okay? It's not like G and F, all right? Okay, hopefully you understand that. All right. All right, guys. That is all for today. Hey, thanks for hanging out with me. Sorry it's on video, but yeah, have a great day. Okay, guys. See ya.